Hello students, welcome to video lesson 8.4. We're going to talk in this section more about linear equations and specifically about the slope of a linear equation. This may be something that you were introduced to previously. We're going to sort of refresh our memories and talk about how we calculate the slope, what it tells us, different types of lines and what their slopes look like. All right, so in general, the idea of slope is something that we sort of understand from real world examples. Your book starts by talking about like a ramp, for skateboarding or biking or whatever it is, and the slope obviously is talking about how steep that ramp is, right? So the slope would be here. How steep is this ramp going up? So a higher slope would mean more steep, right? So a higher sloped ramp would be something more like this, right? And this would be probably a difficult ramp to launch yourself off of. But obviously this ramp has a much steeper slope than this one over here. So slope is really talking about steepness, okay? And slope is described here as a ratio. Okay, it's a ratio, which basically means a fraction. Okay, slope always looks like a fraction. I shouldn't say that. Slope always could look like a fraction. And it's a fraction or a ratio of the vertical change, which we call the rise, and the horizontal change, which we call the run. Okay, vertical change going up and down. If we think about putting a line on a graph like we've been doing previously, the vertical change would be talking about the change in the y value, right? The change in the y value. How much up and down did that line go? And then the run is going to be talking about the change in the x value, okay? One thing that I will tell you is whenever we find a slope, particularly from a graph of a line, our x value, our x change, we're always going to sort of run in the positive direction with the x, and then the y value could obviously go up or it could go down, right? It could go positive or it could go negative, and we'll talk more about that a little bit later. So if we have, let's say, the slope of this line right here, which isn't technically in the coordinate grid, but we can sort of understand the principle of this. We talk about the slope of this line, right? We talk about this point here and this point here, and the rise between those 2 points, meaning how much up did I have to go to get from this point to this point? And in this case, it's 6 feet. Okay, and then the run is how much did I have to go this way to get from that first point to that second point, and that's 10 feet. So we make a ratio or fraction out of those changes vertically and horizontally, and then we, of course, want to reduce that fraction as much as possible. Okay, so you will have to be accustomed to reducing your fractions that you find from your rise and your run, or your change in the y variable and change in the x variable. So in this case, we put 6 over 10 because it's rise vertical over the run. And then we reduce that fraction by dividing both of these by 2. And we end up with 3 over 5. So the slope is 3 over 5, or 3/5 as a fraction. And when we are asked to find the slope, I do always want your answer to be a fraction if that's possible, okay? So positive sloped lines look like this, okay? So if I were to put a coordinate grid, let's see, if I were to put a coordinate grid, and if I were to go from left to right, from the negative to the positive on the x, a line with a positive slope should be going up, okay? As the x value is going up in the positive, going this way, the y value should be going up as well. Okay, so a positive sloped line looks something like this, right, going up. A negative sloped line, as the x is going forward in the positive direction, the y should actually be getting smaller or going towards the negative direction. Okay, so a negative sloped line would look something like this. Okay, so green is positive because as x is going up, y is going up. Blue is a negative slope because as x is going down, y is going down. Okay, so your book has a little chart that shows us this. Positive slope, right? The slope is positive as we go from left to right, like reading the book. Negative slope, the line's falling as we go from left to right. That's negative. The y value is getting more negative or going down. But there are two other options for straight lines, which we did look at in our last video, graphing vertical, perfectly straight up and down lines and perfectly horizontal lines, okay? These have unique slopes, right? They're not positive or negative numbers really. So a perfectly horizontal line, if we're talking about sort of a change in the y direction, well, there is no change in the y direction, right? This whole line stays at exactly the same level in terms of the y value, right? In terms of the vertical, how much up or down it is. So there is no change to the y value. No change in the y value. There is some change in the x value though, right? There's some change as I go, let's say from this point here over to this point here. I do change the x value by 1, 2, 3, 4 spots. So I end up with a fraction like this. And if we remember that the fraction bar is really a divide symbol, this says 0 divided by 4. And 0 divided by 4 is just equal to 0, right? So if you notice that 0 shows up on the top of your slope fraction, then you know that that line must be horizontal and the slope is 0. If we talk about a vertical line, the vertical line is a little bit trickier and somewhat more interesting because what we end up with when we do our slope fraction is we have a change in the y because it's going up and down. So our y is changing. You know, let's say from this point to this point, our y changes by 2, goes up by 2, but our x value does not change. So there is 0 change to my x, right? There's no run. I'm not going anywhere left and right. So I end up with this fraction 2 divided by 0, but 2 divided by 0, just like any other number divided by 0, that's not really allowed, right? We're not allowed to divide things by 0. If we try that on a calculator, it would tell us error because we can't divide by 0. So what we say then is we say that that slope is what we call undefined. Okay, an undefined slope is basically changing vertically but never going anywhere horizontally, okay? It's basically like as steep as a line could possibly get, right? Like rock climbing. The slope then is undefined because we can't come up with a number value for something divided by 0 in this case, okay? So those are your 4 options for slopes. They can be a positive number, they can be a negative number, they can be 0, or they can be what we call undefined, all right? Now in your practice problems tonight, I'm gonna be asking you to find the slope between 2 coordinate points, okay? Find the slope between 2 coordinate points. And we have this formula that we can use. It involves 2 subtractions, and then we just make a fraction out of those 2 subtraction answers. And it says m equals y2 minus y1 over x2 minus x1. And what I mean by these y2 and y1 and x2 and x1 is really just the x and the y coordinates of the points that you're trying to find the slope between. So for example, I might be asked to find the slope between the points 2, 5 and -1, 4. Okay, so if I'm asked to find the slope between these 2 points, I just need to identify their x and y coordinates and then put those into my formula, okay? So this I'm gonna call point number 1. Okay, 2, 5 is gonna be point number 1. So I call the x coordinate x1, right? The x coordinate of my first point. And I call the y coordinate y1, okay? And then I do the same thing for point number 2. I call this value x2, and I call this value y2. So it's the x and y coordinates of the 2 points that I'm being asked to find the slope between, okay? Now, m, by the way, is generally the mathematical letter that we use for slope. I am not 100% sure why that is. I think it has something to do with some French word that sort of means slope, or I don't really know. But we use m for slope. And then this formula allows us to, as we can see, create a fraction out of this subtraction answer and then this subtraction answer. All right. Now, if I go ahead and I do this for this particular example, y2 minus y1 is 4 minus 5. And then on the bottom, -1 is the x2 and 2 is the x1. So I do these two subtractions. Now, it's really important, you guys, to make sure that you understand what's happening with your negative signs, okay? Because when we subtract numbers, oftentimes we get an answer that is negative. And then when we make a fraction out of negative numbers, if we have a negative number over another negative number, right, then the negatives can cancel each other out. If one of them's negative, then the whole fraction stays negative and the negative signs don't cancel out, okay? But do make sure that you're sort of keeping track of that. This is one example here where when I do the top subtraction, 4 minus 5, I get -1. When I do the bottom subtraction, -1 minus 2 makes -3. So I can cancel those negatives, and my final answer for the slope would be 1/3, okay? This fraction would be my slope. So when you're given two coordinate points, finding the slope is just a matter of doing two subtractions. You subtract the two y values in the points, you subtract the two x values in the points, and you make a fraction out of those, okay? The y, the vertical, the rise always goes on the top, okay? Number one mistake that I see students make is you do the two subtractions correctly, but you put the x subtraction on the top and you put the y's on the bottom. Okay, you got to remember that the y, the vertical part, always goes on the top, okay? So think about y coordinates going up to the top of the fraction, okay? If we look at a few more examples of this sort of idea, where we're asked to find the slope of the line that's through these two coordinate points, and then say whether it's positive, negative, 0, undefined, okay? That'll obviously be a part of our answer. If we look at these two coordinate points, 2, 3 and 4, 5, again, I'm just going to write for myself that this is x1, this is y1, right? Because it's x, y. Then this is x2, and this is y2. So when I do my subtraction formula, I need to do, let's see, y2 minus y1 would be 5 minus 3. And then x2 minus x1 is going to be 4 minus 2. Okay, so when I do these two subtractions, my answer on the top is 2, my answer on the bottom is also 2. So now I have a slope fraction that I just need to reduce, and then we'll see maybe we can write it in a little bit simpler way. Now 2 over 2, both of these numbers can be divided by 2, right? Or we can just sort of recognize that when we have the same number on the top and the bottom, that fraction is really equal to 1. 1 over 1, and anytime I see a 1 on the bottom of the fraction, remember that I don't really need it to be there. So this slope would just be 1. Okay, that slope is 1. Now, if I go, let's say, to this example here, I'll go to number 7. And I'm asked to find the slope between -7, 4 and 5, 4. So again, I'm going to recognize this is x1, this is y1, this is x2, this is y2. I'm going to subtract the y coordinates, 4 minus 4, over, in this case, x2 minus x1. Okay, so here's something to note. Notice that the bottom with my x's says 5 minus -7. When I minus a negative, that really changes to plus a positive, right? So do remember that the bottom is now going to be a 12. The top, 4 minus 4, well, that's 0. So 0 over 12 is like 0 divided by 12, and that is a slope of 0. right? So my slope here is 0. Now, if I jump to number 6, and I might move some of this stuff out of my way. Okay, if I jump to number 6 here, I'm going to do the same thing. I'm going to find my x1, my y1, my x2, my y2, and I'm going to start to do my subtractions. y2 minus y1, so that's -1 minus 3 over x2 minus x1, which is 6 minus 6. So the top of -1 minus 3 more is going more negative, so we're at -4. The bottom says 6 minus 6, that's 0. So if I do -4 divided by 0, my calculator will tell me error, right? Because I can't do anything divided by 0. So when I find an error in my slope, right, when I try to divide by 0, remember that is called undefined. Undefined slope. The slope here is undefined. Okay, so this process is what I'm going to ask you to do in your practice problems. Okay, take 2 coordinate points, identify the x's and the y's, find me the slope using this formula right here. Okay, m is equal to y2 minus y1 over x2 minus x1. Make sure that is somewhere in your notes to use for your practice problems. If you have any questions about finding slope between 2 points or what the slope is telling you, do please reach out to me. Be happy to help or re-explain. Otherwise, that's all I have for you right now, and we'll talk to you soon.